Back to the C programming language in action. In this module, we're going to explore expressions specifically. Of course, we've used expressions throughout this course already, but in this module, I want to focus specifically on expressions as the focus of our study. Expressions are the most essential building blocks of any program. Expressions produce values from other values, variables, and functions. An expression might be as simple as a value, such as 1, 2, 3, or the name of a variable, whose value is then returned, and so on. Join me as we explore the power of expressions. So I'm going to introduce some basic expressions and their role in computation. Many things in C are considered expressions. That's a good thing, because it means that they can be used in many places, as part of many statements that require expressions here and there. But C++ goes further than C in defining certain things as expressions, such as assignment, which C still does not. Still, for the most part, you can write expressions that mean the same thing in C and C++. Here is a simple example. Here, 48 is an expression. It's the simplest expression, a simple value. The result of this expression, the value 48, is then assigned to the variable called eggs. This expression happens to have been used as part of the variable's initializer, just one of many places that an expression may be used. Here's another. Here the expression is eggs divided by 12. This expression takes the value of the eggs variable and divides it by 12. Again, the result of the expression is used to initialize the dozens variable. As we discovered in the previous module, we need to use expressions as the condition of various statements. We might want to print out how many dozen eggs we have if and only we have at least 1 dozen. Here, dozens, the variable is itself an expression used by the if statement to determine whether to execute its compound statement. If the value of dozens is non-zero, then the message will be printed out. Let's check. Neat. 4 dozen in 48. But we can just as easily use the original expression as the condition expression. Of course, our program is now computing the value twice, since that same expression appears in 2 places, and the value of the eggs variable does not change from one expression to the next. Now, with the basic understanding of expressions, let's now consider some of the operators that may be used to build more interesting expressions. The glue that holds an expression together, or the building blocks that make up the skeleton of an expression. Although an expression needs some value, whether a literal value, a variable, function, or type name, it is the operators that make expressions interesting and give you the ability to express far more complex operations. So let's go through some of the basics. A function call is an expression. So given a simple function, we can now use the dozens function in an expression or to form an expression. Here, the expression involves passing the value 48 to the function dozens. Of course, we can combine function calls in a larger expression. It's not very useful, but you get the idea. Here the star or asterisk character tells us that the result of the function call be multiplied by the literal value 12. The result is the value of the expression which is used to initialize the variable. You can make a wonderfully complex expression and the compiler will be quite happy to chew on it. It's up to us to make them make sense or be meaningful. Of course, expressions need not only be used to initialize variables or to produce conditional expressions for statements. Expressions can become statements simply by adding a semicolon at the end of them. Here, the dozens function call is an expression whose value is discarded. Is this pointless? Not necessarily. In this case, it is because the function has no side effects, but a function might perform some other useful operation which you might want performed. How about expressions not involving functions? Can they also stand alone without an assignment or variable initializer? Sure. There are two primary operators which are quite useful in C and C++ and that don't require any supporting actors. That's the first, and it's called the increment operator. The value of the x variable is incremented by 1. Yes, again, this is a statement. Throwing a semicolon at the end makes this an expression statement. Then there's the decrement operator. In this case, the value of the x variable is decremented by 1. Let's confirm. Okay, let's check. Looks good. Eggs begins at 48. The increment operator takes it to 49, and the decrement operator takes it back down to 48. Now there is actually two different variants of both of these operators. There's a pre-increment and a post-increment. There's a pre-decrement and a post-decrement. This is the pre-increment. And that's the post-increment. Similarly, this is the pre-decrement. And that's the post-decrement. What's the difference? Well, in this case, there isn't any. You see, the difference only presents itself within the expression. Having the operator stand alone with a semicolon terminating the expression and forming a statement seals the difference away from anyone to notice. But just because these operators can stand alone to form a statement doesn't mean they must. Let's simplify things. Now, let's say we want to increment eggs, but also need to know what the value was before it was incremented. That's the post-increment operator, so now before will be 12 and eggs will be 13. Before gets a copy of the value before eggs was incremented. Or we can use the pre-increment to use the incremented value within the expression. Now, after is 14 and eggs is also 14. So after grabbed the value after the eggs variable was incremented. The key distinction is that the pre-variants return the incremented or decremented values to the expression directly, while the post-variants return the previous value. Let's check. So, the first post-increment returned 12, and the following pre-increment returned 14. Okay, now let's have a look at a variety of operators available to C and C++ programmers. In this segment, we're going to take a quick look at many of the different operators available to us. These operators are quite intuitive if you think in terms of maths and logic, so it shouldn't be too surprising. There are a few surprises, but nothing that will cause you harm, and you can learn the full range of operators as you progress in your use of the C programming language. We'll cover many of these operators during the remainder of the course, but I want to quickly give you a tour of some of the most essential, so you're at least familiar with them. That means this won't necessarily be that meaningful an example, but it will give you a sense for what's possible. So, given two variables, we can determine the area quite simply. The perimeter can be calculated quite simply as well. Here we need to create a parenthesized expression to ensure that the width and height are added before the sum is multiplied. For the most part, operators follow the natural precedence of mathematics. Parentheses allow us to override this natural ordering. There are operators which may be used to perform the same operation. If we wanted to increase the width, we might use or even. Each has its uses, and the flexibility allows you to express precisely and concisely what your intentions are. There are also relational operators. Although the statements expecting condition expressions will accept any non-zero value as true, we can also explicitly use operators that return a true-false result. We can determine whether we have a square, whether it's wider than it's tall, or taller than it's wide. If it is not a square, and so on. Let's see what the compiler has to say. Yep, the area is 20,000 and the perimeter 600. It's taller than it is wide and it is not a square. Cool. So we can perform fundamental computations, calculations, ask questions of our data, and act on it. There are many more operators and variants of operators, but they're easily discoverable. Now, let's consider what happens when data types are mixed or exceeded. In this segment, I want to show you what happens when you mix types, how the results are calculated, and what the type of the result might be. This follows what's known as the usual arithmetic conversions, but I don't want to dwell on legalities, but rather give you a sense for what will happen, an intuition. If you're confused, just avoid the problem. Avoid mixing types you aren't clear will result in meaningful results. I've already alluded to this in a previous module where we looked at temperature scales or temperature scale conversions. We switched to floating point values, partly to accommodate Kelvin, but also to simplify conversion. Recall that converting from Fahrenheit to Celsius requires the use of 5/9. That's a fraction, and not an integer or whole number. So how would we express that in C? What's the result of this expression? In C++, you can avoid answering this question. Here, we tell the C++ compiler to deduce the type of the variable based on the resulting type of the expression. Similarly, what's the result of this expression? Well, C does not allow us to shirk this question. This code actually compiles in C due to some arcane rules, but the resulting variables are still assumed to be integers regardless of the expression that they are initialized with. We need to tell it what type these expressions result in, or at least what type we'd like the expression's result to be converted to. Fortunately, the answer in this case is simple. Both operands, both values straddling the operator, are integers, so the result will be an integer. But what will be the result? 5/9 is a little over half, and 9/5 is 1.8, neither of which can be expressed with integers, so the results are truncated. Let me show you. So 5/9 ends up with 0, and 9/5 ends up with 1. Neither is particularly accurate or helpful. Predictably, you can avoid this problem by switching to floating point values. 5/9 expressed with floating point values will produce a floating point result. And 9/5 expressed with floating point values again will produce a floating point result. So that's pretty straightforward, but what happens when we mix it up? Let's flip back to C++ for a minute. Again, we're asking the compiler to deduce the type of both variables based on their initializing expressions. In either case, there's a floating point value and an integer. Who will win? Well, given that information would be lost if the result were converted to integer, the remainder would be thrown away. Given this fact, the compiler decides to treat these as floating point operations, yielding a floating point result. So we can safely say that the results will be double and not integers. Let's see. Great. So the same principle applies when dealing with integer values of different sizes. If you multiply a single byte or 8-bit integer with a 32-bit integer, the result will naturally be a 32-bit multiplication operation, resulting in a 32-bit value. This is the obvious and correct choice since it produces the lowest risk of loss of information. And that's the point. Expressions are what makes interesting programs interesting to write. Writing succinct and elegant expressions that clearly and correctly capture intent, that propel bits from values and variables into other variables and push the application forward, that's what programming is all about. In this module, we've looked a little more closely at the role of expressions in programs, at the way in which expressions capture computation, turning static program code into real, live, and changing values. We looked at various ways in which expressions surface within programs. You can slap a semicolon behind an expression, and you've got a statement. You can build more interesting expressions with operators, combining values, variables, functions, types, and more. And we looked briefly at how types are converted and convertible to support the least loss of data, but do remember that the compiler is not omniscient. It cannot possibly know exactly what you're after. You still have to make intelligent choices about types, data, and the expressions you're developing.